All right, we're going to get started. So for those of you that have been aching to do logs on your calculator and don't have a newer calculator for which that is possible, we're going to learn today how to take the log of anything, not just log base 10 and log base e. So what I want you to do is approximate log base 3 of 12 to 4 decimal places. We kind of did this when we went to introduce logs. It is a necessity for logs. Remember how we did this? We said 3 to what power equals 12. So we consider the exponential. So you're going to need a calculator. Yeah. So try and get as close as you can to 4 decimal places. 3 to a power is 12. 3 squared is too small. 3 cubed is too large. More? And if you had to add another decimal place, Lauren, what would you add? So after that, too, would you do 1 something? Andrew? 1 9? What do you guys think about 1 9? Super close to 12. Pretty good? Okay. So that's approximating the logarithm through the whole guess and check method. Let's see how we would actually find it on a calculator, which is more advanced. So what we can do is what's called the change of base formula. So the change of base formula allows you to change any base to anything you want it to be. So it's kind of magical. So if you have log base A of m, you can change the base of that to log base b, where b is any base you want that's, not negative, not 0 or 1. Log base b of m over log base b of a. So and this here just demonstrates that you can use any log, and given what is easily accessible on your calculator, you probably want to change it to either the common log or the natural log here. So if you wanted to find exactly the log base 3 of 12, it would be the common log, for example, of 12 over log 3. That's how you change the base. Or you could write it as ln 12 over ln 3. You can change it to anything you want as long as the base on the top and the bottom is the same. And were we pretty close with our estimate here? Can you guys do that? What is it when you do log 3, no, log 12 over log 3? Off by thousands. And it doesn't matter what you change it to. If you guys tried out ln of 12 over ln of 3, it should be the same exactly. So now you can do any log you want. Awesome. Now I'm going to demonstrate to you kind of why this is true by solving this equation 2 different ways. One way I'm going to solve it is I'm going to put this into log form. So log form would say log base 4 of 11 is x. So that is log form, and I solved for x because I isolated x. But the other way to do these problems is to take the log of both sides. And when you take the log of both sides, this is what it looks like. Log of 4 to the 11 equals log of 4 to the x equals log of 11. So as long as you do the log of the same base on both sides, it's a legal move. And so now, because of the property you learned yesterday, we can write that x up front. Okay? So this is equivalent to x log 4. X log 4 equals log 11. And lo and behold, when we divide both sides by log 4, you get another representation for x. So x equals log base 4 of 11, and x also equals log of 11 over log 4. Proving algebraically that these are the same thing. Change of base. There's this awful band in like the mid-90s called Ace of Base. It's terrible, but I think of them when I think of the change of base rule. So if you want a really bad song to get stuck in your head, go to YouTube, look up Ace of Base. Log base 3 of 7 would just be log 7 over log 3. Right? It's saying 3 to what power is 7? We know 3 to the first is 1, 3 squared is 9, so it has to be somewhere between 1 and 2. What do we get to 3 decimal spots? Noah?
1.771.
There we go. So now you can do any log you want. The door is open. Now, the way I remember which to put on the top and which to put on bottom, because the change of base rule, while you're like, oh, there's something, you know, like a year from now when you're asked to remember all this pre-calc, just remember the bigger number, okay, like physically, the number that you write bigger goes on top in the formula. And then you'll get it right. And if I wanted to graph log base 5 of x on my calculator, log base 5 of x is just y equals log x over log 5. So now I can graph logs of any base on my calculator. Now, if you guys wouldn't mind opening up your graphing calculators, I just want to demonstrate to you how this is kind of a flawed like if this is your go-to way to graph logs, you can come up with another plan. Because while you can definitely bring up a graph, the calculator doesn't handle logs terribly well. So if you type in y equals log x, and that parentheses after the x, divided by log 5, I just want to show you what I'm talking about here. I'll just get a y equals. Okay. Log x over log 5. Log x over log 5. I'm going to turn that off. That to go away. So when most people look at the log graphs on the calculators, they incorrectly think that it somehow like starts right here and then goes up. So you need to know more about the function than the picture really provides here. You need to know that it does not start there. It starts at negative infinity as asymptotic behavior, and then it will slowly grow up. But you can still see the shape, the location, but you do have to know more about the graph than the picture would show. Questions on that? Did I lose my spot? Ooh. Let's practice what we learned yesterday a little bit. Express y as a function of x. So in other words, you want to solve for y. Now, in order to solve for y, do you guys see how you have ln on the left side, but you have a ton of ln's on the right side? We want to remedy that. So I am going to rewrite this as the natural log of y squared equals I think I'm going to write this as ln of the cube root of x squared plus 1, because that one's positive, that one's negative. So it's over the square root of x. Okay? So because the half ln x is negative, that goes on the bottom. So this is this one. This is this one. Ln of c gets multiplied. So the c you can just multiply up here. I'll just throw a c right here. Questions on that? So then, because I have just an ln on either side, I can say that y squared would equal c times the cube root of x squared plus 1 over the square root of x. And then y is the square root of all this, plus or minus. So because you were able to write both sides as ln, ooh, yeah, this is okay. This is good. Yeah, okay. So this does not require simplification. We're just going to call this good. I mean, it's anything but good. It looks like a compliment, but we're going to call it done, at least. Time to go.